Welcome to the third video in this web scraping series, where we will show you everything about web scraping, from how to collect data, how to store it, and even how to avoid getting blocked. In part 1 and 2, we learned how to build a basic scraper, extract data from websites, and then clean that scraped data. If you haven't seen parts 1 and 2, make sure to check them out. In this part, we're going to explore everything to do with saving and storing the extracted data. We will cover saving to JSON files, storing files to AWS S3, and even how to insert our scraped data into MySQL and Postgres. Just to note, all methods for storing data into JSON files, databases, or S3 buckets will be implemented within the product data pipeline class, which was created in part 2 of this series. If you haven't seen it, make sure to check it out. Firstly, we're going to take the data we've extracted and we're going to save it in JSON format. To do that, we need to import the JSON module. Then, in our constructor, we can take a JSON file name argument, and we can set the attribute JSON file name, just like we did with the CSV file name. Now let's define a save to JSON function, just like the save to CSV function. We will create a products to save list, a JSON data list, and we will extend the products to save list using what's in the storage queue. If there's nothing in the products to save list, we will just return because there's nothing to save. However, if there is, we will loop through each product in the products to save list and append the product as a dictionary to the JSON data list. We will then try and catch a file not found exception, and in our try block we will open the JSON file in read mode with the UTF-8 encoding, and we will read the existing data from that file using JSON.load. If the file doesn't exist, the exception will be thrown and existing data will be an empty list. If it does exist, the JSON data will be read from the file. We will then extend the existing data list with the scraped data. Then we will open the JSON file again, but this time in write mode with encoding UTF-8. And to write to this file, we will simply say json.dump the existing data, the output file, and the indents in the file. To actually save to the JSON file, we will go back to our close pipeline function, comment out save to CSV, and instead call save to JSON. In our product data pipeline, we will then give a JSON file name. Here it's productdata.json. And then when we run the script, a new file called productdata.json will be created, and inside will be the JSON data that was collected. Next, we are going to see how we can save these files to AWS S3. To interact with AWS, we need to download the Boto3 library. Before we do that, let's activate our virtual environment. And to install Boto3, we simply type pip install Boto3. Once we've done that, we can now import it into our code by simply writing import Boto3. Now, let's create a save to S3 bucket function that is very similar to the save to JSON function we just created. Let's define our AWS access key ID and our AWS secret access key. These can be retrieved from your Amazon account. Next, we will create an S3 client instance by saying boto3.client and passing S3 as an argument. And we will also pass our key ID and our secret access key. We will then use the S3 client we just created and call s3client.putObject to put the object into a particular bucket. We will have to pass in the name of the bucket. So for now we will say self.aws s3 bucket, the key, which is the actual name of the file. So for now we'll say chocolatedata.csv, and the body of the file, which will be open and the productdata.csv in read and bytes mode, which will allow us to pull the data out of the file and send it to S3. We can then get the status of that request from the response metadata and get the HTTP status code. If the status code is 200, then it was successful, and we'll print that out. However, if it was not 200, it was not successful, and we can print that out also. Just so we can debug the issue if it arises, we can also include the status. In the constructor, we will put in our AWS S3 bucket name. And then just like before in the close pipeline function, after we save to the CSV file, we will then save to the S3 bucket. Now when we run the script, you can see it prints successfully put on S3 bucket. And when we open up the AWS console and refresh the file list, you can see that the chocolatedata.csv file has been uploaded successfully. Next, I'm going to show you how you can save the extracted data to a MySQL database. Just like before with S3, to be able to interact with a MySQL database, we need to install a library. Before we do so, make sure to activate your virtual environment and install the MySQL library by saying pip install MySQL connector Python. To create the table, open up your database client and run this query. This will create a chocolate products table with the required fields, and we can check what's in that table now using this query. As you can see for me, there's nothing in my table yet. So to interact with the database from the code, we need to import MySQL connector, and then let's write a function called save to MySQL. We will create a list called products to save, and we will extend it using what's in the storage queue. So what's in the storage queue will get copied into the products to save list. If there are no products to save, just like before, we will return. However, if there are, we will first create a connection by using mysql.connector.connect, giving the host name, which for me is localhost, the database user, which for me is root, the database password, which for me is password, and finally the database itself, which for me is chocolate. We will then open a connection cursor and loop through every product in the products to save list, convert each item to a dictionary using asdict, and then using the cursor execute a query, in this case an insert query, by saying insert into chocolate products and the fields we want to insert. We will use %s as placeholders for the values, and the second argument to the function call will be the values themselves in the item dictionary. Finally, to actually commit this change to the database, we will just call self.connection.commit. So just cleaning up, we will add some function calls into the add product function, the save to S3 bucket, save to JSON, and save to MySQL. But for now, let's just comment out the first three because we just want to save to MySQL. Same goes for the close pipeline function. Up until now, we've been using dummy data, but let's use the actual data we are scraping. So let's remove the dummy products, move the scrape data function to just after we define the data pipeline. And inside the start scrape function, let's call data pipeline.add. Now when we run the script, you will see it will complete. And when we open up the database again and do another query, you can see it's been populated with all of the data from the database. For Postgres, it's very similar. Open up your database client and create a table in your Postgres database. I can do another similar select query to check the table for any data. Coming back to the code, we have to activate our virtual environment again as we need to download another library. This time it's pip install scopg2. Just like with MySQL, we have to import scopg2. And let's create a function called save to Postgres. Again, we will create a products to save list, and we will extend it using the storage queue. If there is no products, we will just return. And like with MySQL, we will create a connection using the imported library scopg2.connect. We will provide the host, which again for me is localhost, the database, which for me is Postgres, the user, which for me is Postgres, and finally the password, which for me is password. We will open the connection cursor just like with MySQL, loop through each product in the products to save list, convert the product to a dictionary, and then execute a query and insert query into the chocolate products table. Again, we will use placeholders for the values, and these will be filled in by the second argument. We will then call commit on the connection to commit this change to the database. And just like with the other functions we've created, we will also call save to Postgres. Now when we run this in the console, and then we open up our database client and query the chocolate products table, you can now see that there's a bunch of products in the table. So that's everything we're going to cover in this part. We hope you have a good understanding of how to save the data you've scraped into a file or a database that you need. As always, if you have any questions, please leave them below. In part 4 of this series, we will learn how to make our scraper more robust and scalable by handling failed requests and using concurrency. Make sure to check out that video. Also, don't forget to like, comment, and subscribe.